Okay, we're going to take a look at covalent bonding today. So far we have learned how to differentiate between ionic and covalent bonding, how the two different types of bonding are different. And then we took a look specifically at ionic bonding, looking at how ions form charges, how those opposite charges attract to one another to form a bond, and how we name and write formulas. So quick review of ionic bonding. Atoms form ions by gaining electrons or losing electrons. When we gain, we form negative ions, and when we lose, we form positive ions. These opposite charges attract to one another, so positive attracts to negative. The ratio between the ions must be such to form a neutral compound, which means we have an overall charge of 0, and we add subscripts to get that overall charge. When we name ionic compounds, we name the cation, the positive thing, right off the periodic table. The anion, the negative, we name off the periodic table and then change the ending to IDE. There are some special considerations for polyatomic ions and transition metals, so if you need to review those, go back and take a look at your Matter D notes from level 4. Covalent bonding, then. This is different than ionic bonding. In ionic bonding, we had ions becoming charged due to the gaining or losing of electrons. But in covalent bonding, we actually have those atoms sharing electrons in order to fulfill their outer ring. So if we remember, the outer ring here has to have 8 electrons. The only exception is that first row where they only want 2 electrons in the first ring. But normally almost every element wants 8 electrons in their outer shell. So when we are gaining or losing electrons, we are either gaining or losing to form that full outer shell of 8. Now, in covalent bonding, they share. So we can see here these 2 fluorine atoms. We see this one has red dots, this one has blue dots. If they share these 2 in between, so the blue one shares the red shares with the blue, they now have 8 in that outer ring. Okay, this pair up here that is not bonded, same as this pair, same as this pair, those are called lone pairs. Okay, they are not bonded pairs. This pair here that holds these 2 together is what we call a bonding pair. Okay, so this sharing of electrons is what holds these 2 atoms together. Okay, neither of them is charged, neither has a positive or a negative. They're held together through that sharing. Think of it kind of like when you share something with a friend, you guys kind of have a common connection then. These 2 elements have a common connection through the sharing of those electrons. Atoms can share with more than just 2 electrons. So for every 2 electrons that are shared, we call that a bond. Each set of 2 atoms can share up to 6 electrons. So if they're sharing 2 electrons, then they have a single bond. If they're sharing 4 electrons, they have a double bond. And if they're sharing 6 electrons, they have a triple bond. The more electrons shared, the shorter the bond is. So again, thinking back to that sharing with a friend, the more things that you share with your friends, probably the closer your friendship is. So the more electrons that these elements share, the shorter the bond is, or the tighter they're held together. We have some pictures here. Hydrogen and hydrogen only have a single bond. Oxygen and oxygen have a double bond, and nitrogen have a triple bond. Now, the number of bonds, or the number of shared electrons, is determined by how many electrons need to be shared in order to fulfill that 8 valence electrons. Valence electrons are what we call those outer electrons. You'll hear that term more as we go. Shared electrons can come from either element in the bond. It's not always an equal partnership where one element gives 1 electron and the other element gives another electron. Most often, that is what happens. So each element is contributing 1 electron to that shared twosome. We can see that here in that picture with this red from hydrogen and the blue from carbon. So each of these bonds are a red and a blue. When we get to drawing pictures of these things, it really doesn't matter which element gave up its electrons to form that bond. What matters is that that bond is occurring. Sharing is also not always equal. Think of it when you share things with your friends or your siblings. You don't always have an equal partnership where everybody gets it the exact same amount of time. Sometimes one atom needs the electrons more. Okay, we can determine which one needs the electrons more by the electronegativity value. We've been talking about electronegativity here in the last few units. We have those tables, those periodic tables that show the different electronegativity values. If we have a higher electronegativity value, that means that that element has more need. So polar covalent bonds means one atom needs the electrons more, creating an unequal sharing. If we look down at this picture, okay, first we'll talk about the ionic. The ionic is where they're not overlapping here. These circles are not overlapping. A gave up its electron to B, which is why there's this two lone pairs here and why we have those charges. But notice their circles don't overlap. B is much bigger than A because it's taken on some extra electrons. In a polar covalent, we have A and B sharing, so they overlap with these two electrons in the middle, but notice that B's circle is bigger than A's. That means that these two electrons that are being shared spend more time over here with B. So they circle, circle, circle B, and then every once in a while they go and circle A. And then they go back and they circle, 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 and they go back and circle A. Okay, in nonpolar, both atoms have a similar need. Now, it doesn't always have to be an exactly equal need, but they have a very similar need, which means that these electrons that are being shared are shared equally or almost equally, so close to equal that we can call it equal. So they circle, circle, circle A, and then they circle, circle, circle B, and then they go back and circle, circle A, and circle, circle B. Okay, so the amount of time spent on each A and B is the same. Now, naming covalent molecules. When you are given a formula, so letter for an element, subscript, letter for an element, subscript. You name that element and then you add a prefix. The word prefix means that it's a word that is attached to another word that means something. Okay, and our prefixes here tell us how many of that atom are bonded. We only put the prefix mono on the second element, and you need to memorize these prefixes. Okay, so if it's a 1, then it's mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hepta, 7 is hexa, 8 is octa, 9 is nona, and 10 is deca. So for these covalent molecules, we don't need to know, does it form a +1 charge? Does it form a negative charge? We don't need to know any of that. We just look at the formula, see if we see a 2 subscript on a carbon, then it means we write dicarbon. Okay, we're going to practice a few of these here. So, examples. Name the following. NO. So we know that N is nitrogen. There's no subscript here, which means an invisible subscript means that it's a 1. Okay. Oh, that should be monoxide because there is no subscript, which means it's a 1, and this is oxygen, so change that C to a D, monoxide. That means that our name is nitrogen monoxide. For H2O here, okay, we have H is hydrogen. There's 2 of them, so that means we're going to write dihydrogen. O, there's only 1 of them, so we're going to write monoxide. Now we got dihydrogen monoxide. Now notice that I didn't put a mononitrogen up here. I just put nitrogen. We only put the mono on the second element. Some more examples. For finding the formula from the name, it's just as simple as what we did before. We look at what is the prefix and what is the word. Okay, so carbon, that's a C. I have no prefix, which means it's just a 1. I have fluoride, or fluorine, because remember we still change that ending. We got fluoride, and then we have tetra. Now, if we look back at those prefixes, tetra means 4. So we have 4 fluorides, which means we have C, F, and a subscript 4. That means 1 carbon and 4 fluorines. Okay, dinitrogen pentoxide. Di here on the nitrogen means that we have, oh, I'm sorry, that went away. Di here on the nitrogen means that we have 2. Nitrogen is the N, so we have 2 nitrogens. Pent is the prefix for 5, oxide meaning oxygen, so we have 5 oxygens. We look and that gives us N, prefix or subscript 2. O subscript 5. So N2O5 is dinitrogen pentoxide. Okay, that is all the new information we have. Take a look at your practice sheet. That's going to wrap up with a few practice problems, and then go ahead and work on your choice activities. Let your teacher know if you have any questions.